SQL in models. So today we will be looking at how we create hierarchies, how we query hierarchies, or how we create table functions, for example. So we will be doing that. Before going into the details of today's content, let me first take you to the learning journey page. I am doing that because if you want to take the certification after you go through the learning journey, I think I discussed this in the first session also. Then this is the landing page where everybody has to start. So let me just start with that, and then we will be taking to the technical sessions. So if you can see my screen, this is the learning journey page for modeling in SAP HANA Cloud. We will be sharing the link of it in the chat window. So all the content that has been delivered or will be delivered during this Partner Certification Academy training is basically based on this learning journey. This learning journey, as you can see, it is 12 units, and total, if you do it yourself, it will take around 16 hours. So here in the Certification Academy, we deliver this content in a condensed version to you in the form of trainings. So if you want to check this content yourself, you have to visit this link. As you can see, if you scroll down here, each and every unit is mentioned, that what all units are there, how much time it is going to take, what are the sub lessons. And if you go to any of the topics, for example, create a project in SAP Business Application Studio. So if you go through this, you will see that it has some videos. You can go through these videos, and also there are some simulations that are available. So if you click on any of them, you will see that there are simulations that you can use if you want to get some hands-on experience on Business Application Studio. So here, if you just click Start Simulation, it will guide you through the basic steps. You have to click on wherever it asks you to click, but it is a simulated version. So if you click here, then you will be able to actually do some hands-on on the system. So this is the basic landing page of the learning journey content. And also, if you see here, you will find the details of the certification. So if we go back to the learning journey page and we scroll, here is a SAP certification page. Book your certification exam. If you see here, it has 80 questions, total 3-hour exam. And after going through this Certification Academy training, you can attempt this certification exam. If you click on View Certification, this is the certification page. As you can see, the cut-off score for this certification is 64%. And if you click on View Sample Questions, then you can go through some questions also that you will find very interesting. And these are exactly same kind of questions, and the format is very similar to what we get in the original certification exam. So this is how the certification landing page, and this is the certification code. So this is the overview of the learning journey content. This is the percentage distribution of all the topics that we are going today, and also that we went in the last session. What is the percentage of each and everything? So that if you go through one unit, I think you will be able to attempt this percentage of the learning journey content. So this is the basic. Of links for the first session, and wherever you will get the further recordings, and the PDF version of this presentation will be shared in today's session. So I will be sharing the link with all of you, and that folder is password protected, so I will be sharing the password also. uh, I would request all of you to just try logging into that session, the folder, and see if you have the access. Right now I have not uploaded the files, but I will be uploading the files today for the first session, and today's session after the end of today's session. So like it will be available by end of the day today. So this was the overview of the learning journey page. Now let's go back to the technical content. Please give me a moment. Yes. So let's start. Let's start with the today's agenda. So today we will be going through two units. The first unit for today is modeling functions, in which we will be taking you through various kind of modeling functions that we can use in the graphical calculation views, like restricted columns, calculating columns, the input parameters, data filters, hierarchies, and currency conversions. After that, in the second unit, we will be using how we use SQLs in the data model. Here, we will be getting you through how to use SQL script. What is the difference when you use a script-based view and a graphical calculation view? When to use what, and also how we create table functions, and also how we use scripts to create like tables, and how to import data into that table. Like these kind of topics. Also, please note that after the end of each unit, we have a poll created. So this poll will have very similar questions to what you get in the certification exam. So these kind of polls are not mandatory to participate, but I would encourage all of you to mark your answers, because that gives a fair idea of if the session that was delivered was helpful. So let's start. So the first unit for today is modeling functions. Modeling functions are the functions that are applied on modeling objects like columns, both attributes as well as measures, or hierarchies, allowed to refine the model and create result sets that are relevant for further analysis. As you can see on the slides, these are the various types of modeling functions that we generally use. We can generate a restricted or a calculated column. We can use a data filter. We can implement variables. We can define input parameters. We can map variables and input parameters. We can define a hierarchy, and also the currency conversion thing. Basically, these modeling functions help us to get the relevant result set out of the generic result set. So the first topic is restricted column. As the name suggests, the restricted column shows the subset of the original column values. The restriction criteria cannot be based on a column defined as a measure in the semantics, but only columns of the type attribute can be used. You can create a restricted column that will restrict the value of the whole set for a certain subset. Like for example, if you can see in the slide, if we create a restricted column for only the amounts where the country is US, then the restricted column will show only the data when the relevant country is US. So how we create a restricted column? As you can see in the slide, a restricted column can be created within an aggregation node or a star join node of a calculation view. You need to assign a measure to the restricted columns and indicate the columns that define the restriction. In this case, the restricted column is based on total sales and it is restricted for the description of the product. The filters for a restricted columns do not have to be limited to one columns because your business requirement might need to filter on multiple columns. The operators can be the usual logical operators like equal, greater than, less than, and you can also flag the hidden checkbox to hide the restriction in case you would like to reuse it in another calculated column. Another option is to define or edit the restriction to use you can use it using an expression. This provides more flexibility when the standard operators for the column-based graphical restrictions do not fulfill your needs. The expression can use column names, operators, input parameters, and also they can include functions. So there are two ways of creating a restricted column. One is like this, and second is the expression-based editor. The next topic is calculated column. In some cases, the measures from the base data are not enough to fulfill your reporting needs, even if you use joins, aggregations, unions, and so on. To solve this extra requirement, you need your calculation views. You might need to transform one or several attributes by creating calculated columns. When creating a calculated column, the first step is to choose the column type if it is a measure or an attribute. You then double click or drag and drop the elements, operators, and function to build the expression. So we can add the elements here, we can add the functions from here and the operators from here. After we have done with the syntax, we can click on validate syntax to validate if whatever we have written is right or wrong. Creating calculated column in an SAP HANA calculation view does not mean that the calculation is persisted. It is simply projected through the generated column, but it will not be saved anywhere. The calculated column is available only during the runtime of the model and can be displayed in the report or consumed by another view. However, to keep this result of calculation over time, one of the following methods can be applied. Firstly, we can create an ad hoc SQL artifact that updates and insert the calculated column into a table. Secondly, we can use a write enable procedure that will also add the values calculated into a table. Thirdly, we can use the transformation and calculation features provided by an ETL tool such as SAP Smart Data Integration or SAP Data Services. Using these methods, you can pre-calculate the columns during the data provisioning phase, and the data will be persisted. So this is how you can persist the data. Now let's go through a demo video in which you will see that how we create a calculated column in the Business Application Studio.
In this demo, we will be creating a calculated column. We have a view CV books, and here we will be calculating a calculated attribute and a calculated measure. We create calculated columns when the base data is not good enough to fulfill the reporting needs. It is faster as we let the database engine perform the calculations. Also, it helps to simplify some complex reporting scenarios. So here we will go to the aggregation node and click expand. Go to calculated columns and click on add. Click expand. So here we will be filling the name, label and data type of the calculated column. First we will create a calculated attribute. In semantics, we have the option of selecting the attribute or measure. So we will be selecting attribute. In the expression, we give the definition of the column. We go to expression editor. Here we have three columns. First is element, where the required columns are visible. The second is functions, where the standard functions are visible. Third is operator, where the basic operators are visible. So we do the calculation here. We can write any expression which is in SQL. So we have written expression here that calculates the range based on the price. If we go to validate syntax, we see it is a valid expression. So the first calculated column is created. Let's create another calculated measure. So if we go here, click expand, here we can give the general details. This will be of the type decimal. In the semantics, we will be selecting measure. We can also enable client-side aggregation if required. In the expression, we will be giving the definition. So this is the total value, which is the available stock into the price. If we go to validate syntax, this is a valid expression. We'll click back and we'll deploy this. Let's see the data preview. The first one is price range. So if we see the count of titles per price range, we can see that we have values high, low, mid and the count of titles with each. Secondly, if we want to see the net value of each publisher, we can see that the values are correctly calculated. Thank you. In this,
So this is how we create a calculated column. Both the calculated attribute and measure was shown. So let's move to the next topic. Validation of expressions. Validating an expression against a specific language has some key benefits. It helps to validate the syntax of the calculated columns according to specified language. For example, an expression with an if condition, which is only supported with SQL script, will not be validated if it is defined as SQL. In turn, it helps the modeler to optimize the calculation execution. There are two languages in SAP HANA Cloud used to validate the expression. One is the SQL and other is the column engine. As you saw in the demo video, there was a checkbox that said enable client-side aggregation. If you want to create a calculated measure and enable client-side aggregation for the calculated measure, select the enable client-side aggregation checkbox, which is mentioned here. This allows you to propose the aggregation that the client needs to perform on the calculated measure. When the flag is ticked, formula is executed and then the aggregation is applied. If this checkbox is not enabled, the aggregation becomes a formula. By selecting the Enable Client-Side Aggregation checkbox, you propose the reporting client to also apply a maximum aggregation if that aggregation is selected as max. The next kind of modeling function that we are going to discuss is data filters. The main purpose of using filters is to reduce the initial amount of data to display the only relevant ones. Using the criteria mentioned as good practice in the slide, let's first see some good practices that relates to data functions. Basically, we use data filters to reduce the number of data for analysis and consequently improve the performance. Some good practices related to data filters are that we should apply the data filters as low in the data model as possible. Secondly, we should minimize the data transfers both between the database engines and between the SAP HANA cloud and end user applications. So the filters should be hard coded as per the best practice. Third is whenever possible, data should be aggregated and filtered to a manageable size before it leaves the data layer. And fourthly, when deciding which record should be reported upon, we should always think at set level and not the record level. I mean, we should always think at the group level rather than thinking about the individual record level. So these are the best practices that are related to the data filters. So where can we apply filters? We can apply filters in all these nodes which are mentioned on the slides. Every node has a data filter option. Filters can be applied to many node types. These include projection, union, join, rank, aggregation, and star join. As a consequence, you generally do not need to use a projection node for the sole purpose of filtering data. To define a filter, you display the filter expression tab and define a valid SQL expression that will give you the criteria of the filtering. It is recommended to use SQL expression whenever possible because they most often allow better optimization. The behavior of filter expression can change based on the node where you apply the filter. Therefore, where you apply a filter and when you apply the data filter matters. For example, if you apply the filter on a top node, which is an aggregation or a start join node, uh, it will filter the data after aggregation. While if you apply it on any other node, then the data will be filtered first and then aggregated. Depending on the location position of the filter expression in the calculation scenario, the output of the result set can change. In these slides, you see the main steps necessary to define a filter in a calculation view and how to use it. The details about this demo is available in your training material where you can find the entire simulation. So as you see, we select the projection and then we do the data out. So we see that this has data for customer ID 1000, 1001 and 3000, 3001. If you want to restrict it for a generic customer ID 3000. Then we go to the projection and apply filter expression. In the filter expression, we just have to write customer ID is equal to 3000 and then we have to validate and deploy. And then if we refresh the data, we'll see that the data output is restricted to a single customer ID and the amount of rows are obviously reduced. The second condition, if we want to apply a filter condition on a measure. Now we want to analyze the sales quantities and identify which customer brought 10 or more pieces. In this case, we will modify the calculation view to add a filter expression at the aggregation node level where quantity is greater than or equal to 10. So we'll again go to the aggregation node, go to filter expression, and then we will add quantity greater than or equal to 2 in the expression box and validate and deploy. After that, if we refresh the data, we'll see that the result set is further reduced and it will only show you where the quantity is 10 or more. So this way you saw that we can apply filters both to the measures as well as to the attribute. Also, we can apply filters on multiple attributes at the same time if that is the reporting requirement. Now it's time for another demo in which we will practically see how we do apply filters in a calculation.
In this demo, we will see how to create and use filters in HANA calculation views. We have a view called CV Books, and here we will be creating filters. We create filter when we want to analyze data on a reduced dataset. Filters can be done on attributes as well as on measures, and also we can create filters using both. The filters can be hard coded and also can be flexible based on input parameters. So here we will be going to the projection and go to expand details. Here we have option of filter expression. Inside filter expression, we have to write the expression here. We can use elements of the columns. We can use functions and we can use operators to create the definition. So here we will be filtering based on the author ID. So we'll see author ID is equal to 30. So this will filter all the author IDs which are equal to 30. If we see the initial data preview of this view, we can see that it has data for multiple author IDs. And if we sort this, we can see that it has data for author ID 30. Now we will activate. So the view is activated. Now let's refresh the data output. So we see that the data is filtered for author ID 30 and the number of rows are reduced to 35. We can also use other expressions like if we want all the authors which start from 3. So we can write like this. Validate and activate. We can create filters on projections, union, join, rank, aggregation and star join nodes. So for adding the filter only, we don't have to exclusively add another projection. Let's see the output. So now we can see the number of rows have increased to 840 and we can see that the authors that are starting with 3 all are present here. Like this. We can similarly create filters on measures. Also, we can create filters that are flexible using input parameters. Thank you.
So this was a demo on how to work with filters. Apart from hard coding or filters that use expressions, there is another type of filtering that are predominantly used, which is the client specific filtering in calculation views. Client specific filtering makes sense only when some or all of the source table have a SAP client column. By default, A calculation view defined in SAP Business Application Studio returns all value regardless of the SAP client value. To implement client-based filtering, define relevant for all source tables, we should have a SAP client column. This is done in the mapping tab of the node where source table is referenced with the client column property. You define how you want to retrieve data. For this, we go to the semantic node of the calculation view and we choose one of the following three options in the default client setting. The first is cross client, second is fixed client, and the third is session client. In the cross client, all the data is retrieved regardless of the client number. This is the default option when you see the settings in the semantic node. The second is fixed client. If you want to specify a client number, for example 200, and the data sources will automatically filter to include rows which are only specified for the client number. The third one is session client. This is where the source tables are filtered dynamically based on the client value that is specified for each user in the users table of the SAP HANA Cloud. In this case, if you see, for tables where no client column is specified, it will fetch all rows. For the tables where the client column, which is MANDT, is defined, then for cross client, it will fetch all the rows. For fixed client, it will only fetch the rows which is for the fixed client value. For the session client, if the user has no default client, it will not fetch any data. If it has any default client number assigned, then it will fetch the data for only that number. That makes it a bit dynamic. So that was about filters. The next topic that we are going to discuss today is variables. When you need to pass dynamic values for filtering on attribute columns, then you define a variable in a calculation view. Variables provide an excellent way of filtering data, and there are many options that makes implementing variables easy and flexible. When a calculation view is executed, variables are passed inside the SQL query using a where clause. You define variables in the semantic node of the calculation view in the parameters tab. The view table value help setting is used to define which table or view SAP HANA will fetch the data to show in the prompt. The reference columns define which unique column in this table or view will provide the possible values for the variable. The behavior of variable at runtime depends on whether an entry is required for the variables or not. These scenarios can be defined as follows. If a variable is defined as mandatory, the user needs to provide the values, ranges, or interval at runtime. For non-mandatory variables, if nothing is specified at runtime, all the data corresponding to the attribute is returned by the view without any filters. So if you can see here, the name of the variable label is mandatory. After that, there is a selection type that says if we have to pass it as a single value or a range or an interval. Then we have a checkbox which says it's mandatory or non-mandatory. Then we have multiple entries. That means if we can select a single entry or a multiple entry. After that, we have the view or table value help. This will this will show the table where the prompt values or the value help for this variable is getting from. And after that, we have to give the reference column. This is the column name of this table where the prompt values will be coming from. So these are the basic elements when we create a variable. In the selection type, there are three possible values. One is a single value. To use this to the filter data on a single value of a column. The second is interval, when you want to specify a interval between two values of the column. And third is a range, when you want the end user to use operators such as greater than or less than. The next topic is input parameters. Input parameters are the artifact that enables values to pass in a calculation view at runtime. They can be used in calculated columns, restricted columns, and data filters. For example, when you want to take an input form from the user and execute a calculation view based on this selection, you need to implement a input parameters. For example, in calculated column, if you want to execute an ad hoc calculation for the forecasted sale for next year based on the current year and overall sales volume increase rate that is provided by the user at runtime, then this dynamic calculation will be dependent on the value that is passed by the user in a specific input parameter, and the values will be calculated at runtime. Similarly, in restricted columns, if you want to calculate in the calculation view the sales of the year entered by the user at runtime and the previous year using two restricted columns, then you have to pass those values in the input parameters. Similarly, in filters, if you want to filter the data dynamically on a value that is passed by the user, then in the data filters, you will use an input parameter and the value will be passed by the user in the input parameter itself. So let's see what are the basic type of input parameters. The following types of input parameters are supported as you can see in the slide. Some are direct and other are like static list, column, or derived from table, derived from procedure, or direct without any semantic type. The direct ones are a direct currency, a direct date, or a direct unit of measure based on a semantic type. Direct parameter types can be combined with a semantic type such as date, currency, or unit of measure. This means that the value held will be based on these type of values. Input parameters of the type derived from table or derived from procedure do not generally generate a prompt except if you select an input enabled option. In this case, the values returned by the table procedure or scalar function can be modified by the end user. Static list means this means that we predefined a allowed set of values that can be chosen by the user in the list. This is working fine for short list, but when the list becomes very large, it becomes difficult to manage as you would have to edit the calculation view and rebuild it each time. Direct without any semantic type means that the user can input anything. But that would mean apart from the user not having any guidance, the user could also mistype the value or enter a value in a wrong format. For example, in dates. That will perhaps lead to incorrect results. A column, which is most generally used in an input parameter type, means that in the view table value help, the user can enter name of a table or view where the allowed entries are present, and this list can be used by multiple input parameters. So here we give a table name and a column name again, and then the values are fetched from those columns which are the allowed set of values. In many cases, calculation view use another calculation view as data source. This is not necessarily limited to two levels because we can proceed further and layer the calculation view to create a stacked model. When you execute a calculation view in which variables or input parameters are defined, it is possible to pass their values entered by the end user at runtime to the lower level calculation views. The input parameters and variables at the lower level are usually ignored unless you define the input parameters and variables at the top level and map them to the input parameters and variables in the lower levels. This feature is called parameter mapping and is crucial feature of SAP HANA calculation view modeling. It is possible to map input parameters from SQL views. This allows a better control on filters and in scenarios where SQL views are consumed by your calculation model. So as you can see in the slide, we can map the input parameters that are used in the views that are used as data sources, like the underlying views. If there is any input parameter defined, we can map it to the input parameter that we create in the top level view. And hence, the any value that is passed in this input parameter will be automatically passed to the lower level, and the data will get filtered or calculated in the lower levels itself. If at all the input parameters that we create in the two views are of the same name, then we have a feature of auto mapping by name, so that each of the input parameter which is having the similar name in the lower levels are automatically mapped to each other. When you open the mapping pane, you must first select the type of the mapping that you want to work with using drop down selector. The list shows four type of parameter mapping, and you choose the type from the manage mapping pane. Please note that you can only map variable to variable and input parameter to input parameter. Cross mapping, such that mapping a input parameter to a variable or a variable to an input parameter is not possible. Once you make your type selection, you will then see on the left side input parameters and variables that are defined in the calculation view from all lower levels in the stack, which is related to the mapping type you selected. On the right side, you will see input parameters and variables that are defined in the current calculation view, the one that you are editing. It's more visible from this slide. Like this is where we are editing, and this is in the lower levels. And this is the select type that they are saying. In this, we have these four options. If you see the first one, data sources, it is the most commonly used one. Mapping parameters from the current view to the parameters in the underlying data sources moves the filter down to the underlying data sources during runtime, which reduces the amount of data transferred across them. This is a great way of improving the performance. So that was the basic theoretical details about input parameters and variables. Now let's see a demo in which we will be creating both input parameters as well as variables.
In this demo, we will see how to create a variable and an input parameter. We create variable when we want to pass dynamic values for filtering on attribute columns. Upon execution of calculation views, variables are passed as where clause. Here, in this view, we will be adding a variable on publisher name. We will go to expand, then parameters, add variable, expanding the variable, giving the name, the label, the variables can be of three types: single value, interval, and range. We can create mandatory as well as optional parameters. We can have multiple entries also in variables. The value helps give the list of possible values. By default, it is from the same view. We can use different master data views if we want to have the value help from master data. Here we will be using the same column that we want to filter. We can add default values, and in apply filter, we will see that the column has been selected. Let's deploy this. Let's see the data output. If we open the data, we see that we get the prompt for selecting the publisher. Here, if we go to value help, we can see that different value options are present. We want to select Collins. We see Collins is present. Click execute. So we see that the data is filtered by publisher column on Collins value. Now let's create a input parameter. Now let's proceed to the next step, which is creating an input parameter. To create an input parameter, we will be going to the semantics and going to the parameters tab. Here we will click on add input parameter. Let's add the details, the label. We can create input parameters of several types like direct, column, static list, derived from table or derived from a procedure. Here we will be creating one of the type static list. In the static list, we can add a fixed list of values from which user can select anyone. So here we have to add the values. So we will be adding values. The first one will be, let's add more. So these are the three price categories out of which we can add a filter. If you want to add any default values, it can be added here. If you want to do any type conversions, it can be done here. So the input parameter is added. Now let's use it in a filter. To use it in a filter, we will go to the projection node. Here we have created a calculated column that has the logic of generating the price category like this. So we will be going to the filter expression. In here, we will be writing the logic price category equals the input parameter. So it will filter the values based on the price category that we are selecting. Let's click on validate syntax. So it's a valid expression. So we'll be activating this view and testing it for the results. So if we see the output screen, in the price selector input parameter, if we pass the value high and click execute and add the price and the titles, we will see that the price has been filtered for values more than 40. So the input parameter is working correctly. Thank you. So that was all about input parameters and variables. The next topic that we are going to discuss in the modeling functions unit is hierarchies. A hierarchy is a structured arrangement of nodes according to a specific order described to describe something. For example, a business organizational hierarchy or a set of structured data. SAP HANA supports two types of hierarchies, namely level hierarchy and parent-child hierarchy. A parent-child hierarchy columns usually contain ID or key fields instead of plain text. In a level hierarchy, heterogeneous fields are combined in the hierarchy and they can have different data types. In a parent-child hierarchy, the relationship between parent and child is defined by a distinct field, the parent field and child field. Both have usually the same data type and a recursive structure defines the hierarchy.
Typically, a parent-child hierarchy column contains ID or key fields instead of plain text. So as you can see, these are examples of same data set presented as a level hierarchy as well as a parent-child hierarchy. So we have region, then we have country, then we have state. So if we defined it as a level hierarchy, we will have a three-level hierarchy in which we have the region, then we have the country, and then we have the state. As you can see, the values here are plain text. The same data set, if defined as a parent-child hierarchy, will only have two columns, parent and child. And here, the country, state, and region are defined as the parent and child of each other. When we define this kind of hierarchy, we usually do it using some key values. So you can see that 1, 2, 3, such numbers are mentioned, but the relationship technically is the same. Lo- or logically it is the same. So the parent child hierarchy structure looks different, but the data output, if you see it, it is the same. In the level hierarchy, we usually need different columns for a different levels in the hierarchy, while in the parent child hierarchy, we need only two columns, parent and child. So how to implement a level hierarchy in 4 steps? These are the screenshots. A level hierarchy is defined by choosing columns from a source data set and organizing them in a sequence that provides a drill down path. Each level is based on a separate column in the source data. The first step is to select the data source that is relevant for the view. Secondly, the columns that should be the part of the view, including any other columns that are required for the hierarchy. They are selected. Thirdly, we go to the semantic tab and we go to the hierarchies and we select add. Fourthly, we add the columns to the hierarchy in the precise order from top to bottom with the lowest granularity at the lowest level of the hierarchy. In addition, you can define ascending and descending sort direction per each level from here. So this is how we define a level hierarchy. Now let's see some features of the level hierarchy. The first one is node style, which is mentioned here. A level type specifies in the semantic of the level attributes. For example, a level type time months indicate that the attributes are months such as January, February, or March. If the level type regular indicates that the level does not require any special formatting. Then there is something called hierarchy member order, which is defined from this button. Using the order by drop-down list, an attribute can be selected for ordering the hierarchy members in the order specified in the sort direction column. Now let's talk about orphan nodes. An orphan node in a hierarchy is a member that has no parent member. Level hierarchies offer 4 different ways to handle orphan nodes, which is root, error, ignore, and step parent. In the root, any orphan node will be defined as hierarchy root node. In the error, when encountering an orphan node, the view will generate an error. In the ignore, orphan nodes will be ignored. In the step parents, orphan nodes are assigned to a step parent that you specify. In the in the node style, there are 3 possible options: level name, name only, and name path. In that, you can if you select level name, then level and node name both are mentioned. If you select name only the name is mentioned. And if you select name path, then it will show the node name and its ancestors all in uh, the text values. So depending on the output, we have to select the node style. Now let's move to the next type of hierarchy, which is the parent-child hierarchy. When creating a parent-child hierarchy, the first step is to define the nodes that make up the hierarchy. The child column contains the attribute used as the child within the hierarchy, whereas the parent column contains the attribute used for its parent. If you want to place orphan nodes in the hierarchy under a step parent node, then in the step parent column drop down list, enter a value that will be for the step parent node. If you want to place the parent child hierarchy under a root node, then in the root node value help, you have to select a value. Now let's see the further properties, advanced properties of a parent child hierarchy. Additional attributes can also be added to the hierarchy, making it easier to report on. The first property of a parent child hierarchy is the aggregate all nodes. The aggregate all node property defines whether the values of the intermediate nodes of the hierarchy should be aggregated to the total value of the hierarchy's root node. If you are sure that there is no data posted on the aggregation node, then you should set this option to false. That means unchecked. The engine then executes the hierarchy faster. The next is default member. Default member helps identify the default member of the hierarchy. If you do not provide any value, all the members of the hierarchy are treated as the default members. The next important node is orphan node. In a parent-child hierarchy, you might encounter orphan nodes without a parent. Orphan nodes property define how these should be handled. For example, if you choose to assign an orphan node to a step parent, the following rules are applied. The step parent node must be already defined in the hierarchy at root node level. The step parent ID must be entered according to the node style defined in the hierarchy. The next important property is the root node visibility. The root node visibility property is used to define whether an additional root node needs to be added to the hierarchy. And the next is cycles. This property is used to define how the hierarchy should be broken into when encountered an error or whether the error should be generated or not. So it has options like breakup at load time. So if there is any error, the hierarchy will break and it will give you an error. That another property of the hierarchy is time dependency. The time dependency is supported for more complex hierarchical data, such that the human resource application within the organization or the material management systems where the bill of material where information might depend on time. Defining a time dependency is only possible in calculation views and for parent-child hierarchy. Enabling time dependency supports hierarchy based on changing elements valid for specific time periods. This allows displaying different versions of a hierarchy. Your source data needs to contain definition columns consisting of a valid from and valid to column. As you can see here, we have two options here. One is a valid from and valid to column, or we can have a key date where only a single parameter can be defined. So if we enable time dependency, we have to specify the column values for time. When an hierarchy needs to show elements from an interval, you have to define two parameters, from and to. If the hierarchy needs to show elements valid on a specific date, then you have to show only one parameter, which is the key date parameter. Now let's proceed to a demo where we will see how to create a level hierarchy.
In this demo, we will see how to create a hierarchy in Business Application Studio. For this, let's first create a view. So we have opened the view creation. We have selected the folder, the name of the view, type, and we'll click create. View is created. In this view, we will add the data related to region, country, and city, and we will create a 3-level hierarchy for the same. So let's add the base table. Click expand. We will add the required fields. Then we'll go to semantics. Click hierarchies. Add a level hierarchy. Then we'll go to level underscore 1. Give the hierarchy name. Then we'll go to the nodes. Here we need to add all the fields, and the top level is the first level, and underneath we just add fields the way we need to drill down. So we'll add region, then country, and then city. There are several options like level type, order by, and sort direction that we can change according to the requirement. In the properties, let's deselect cache. If you want to see the text for any of the columns in the hierarchy, we have to assign it in the label column. Let's see the output. We'll deploy. Let's preview the data. You have to go to the hierarchies and add the created hierarchy. So if we see, we have the 4 regions, and if we drill down, we can see the countries, and if we drill down further, we can see the cities. So this way we create a level hierarchy. Similarly, we can create a parent-child hierarchy also. Thank you.
So this was a demo on level hierarchy. If you want to see a simulation on parent-child hierarchy, that is available in the learning journey content. So the last topic for today's this unit is currency conversion. Many front-end tools are not able to define or switching from translational currency to reporting currency. So this needs to be done and at the modeling level in your data model. SAP HANA Cloud has the necessary functions to perform the currency conversion during the data modeling phase. The key elements provided by SAP HANA Cloud are a set of tables to store master data about currencies, exchange rate types, and exchange rate value, which are these tables that are mentioned in the slides. So basically, these are the tables that are provided in the SAP system that have the data related to the currency conversion. Then we have a semantic type, that is amount with currency, which you set for the measures you want to convert. Then we have calculation view settings to define for each measure how the conversion should be processed, which rate and which conversion date should be applied, and where to find the source and the target currency. To enable currency conversion in SAP HANA Cloud, these tables that is listed in this slide, and if they exist in many SAP systems, must be available. Since the tables are not provided by SAP HANA Cloud by default, you must provide them and update them on your own using any of the data provisioning tools. So now let's see how to implement currency conversion. By default, a measure has no semantic type. When a measure contains an amount, and if you want to enable conversion, you need to change its semantic type to amount with currency code. Note that the semantic type amount with currency code can be used even when conversion is not actually used. In this case, you only have to set the currency property to identify the currency in which amounts are expressed. Once this is done, you can proceed with the definition of setting of the currency conversion. In this slide, if you see, these are the basic settings that we can use while doing the currency conversion. Here, some settings are mandatory while some settings are optional. So let's take a look at the mandatory settings first. First is the client. So it is the client value that you use to filter the Tika tables on. Either the possible options are session client, fixed client, column, or input parameter. Then the next mandatory column is the source currency, which is the currency in which the amounts to be converted are expressed, and this can be a fixed value or a column. Then the next column is target currency. It is the type of the rate used to convert the amount. Sorry, target currency is the currency in which the amounts must be converted. Then it's the exchange type. It is the type of rate that is we use to convert the amount. It can be a spot rate or an average rate, etc. It can be regulated using a fixed value, column, or an input parameter. Then is the conversion date. The date used to match the amount and the corresponding conversion rate is the conversion date. And lastly is the data type. It is the data type of the converted measure, and it overrides the data type of the converted column. Also, we have some optional fields like exchange rate, generate. If we want to have a new column generated, then there is a generate column. Then upon failure, that specifies the behavior if the conversion cannot be executed for any reason. Possible values for upon failure, which is mentioned here, are fail, null, ignore. The fail happens when then the query will generate an error if the currency conversion does not happen. Null will be like if the conversion is not happened, the column will not be populated. Or ignore will be if the conversion is not happening, it will keep the source value. Then last is the accuracy. It defines how the conversion must be performed. The possible options are intermediate rounding or retain all the possible digits. So after the conversion, if we want a rounded off value, then we have to select this one. So this was all about the various modeling functions that we used in SAP HANA Cloud. So this was all about the first unit for today. So now it's time for the first quiz. This will have 4 questions. The format being very similar to kind of questions that you get in the certification exam. So I would encourage all of you to be participative. And after this, we will discuss the right answers. So I'm opening the poll now. Please note that there are 4 questions, some being single choice while others being multiple choice. So please go through them and mark your answers as soon as possible. Last 2 minutes. If anybody else wants to participate. So I'm ending the poll now. Thank you everyone for participating. Let's see the right answers. So the first question was, when is the design time filter expression applied in a calculation view? So the right answers are before the query on the calculation view begins to execute and before any joins are executed. And the second question was, what are two types of modeled hierarchies that you create? So that was the basic question. So it is the level and the parent child. The third question was, which of the following is used to get a subset of the original columns filtered by attribute values? So this is the restricted columns because that gives the subset. And the third one was, which are parameters required to define currency conversions? So this is the exchange type, exchange rate, and conversion. So this is a difficult question because there were so many options available as you saw in the last slide. So the right answers are exchange type, exchange rate, and conversion date. So these were the four questions. So now it's time for a break. Let's take a 10 minutes break, and after 10 minutes let's reconnect to start the second and last unit for today, which is the using SQL in views. So I will be reconnecting. I'm taking a 10 minutes break, and let's all reconnect after 10 minutes. Thank you.